All right. So today we are going to have our last session. Yes, it's so interesting. So as we keep on, we can enjoy our last session. We can have we can keep waiting for others. Yes, we are going to really look at a lot of things, but yeah, our Rust is coming to an end, and next week we are having ink, and today is going to be more of question answers, but also winding up on the Rust bootcamp. So I encourage you to keep studying. Rust is big, to keep researching, innovating, and building. We are a few minutes to getting started, so at around 1910 we shall kick off. 1910, 1915. Next week we shall build on that to make sure that we can handle ink. Yes, so then the coming system we shall look at substrate, we shall build custom blockchains, and many other cool stuff. So let's have our asset builds tight. this is our session 4 and the last session for Rust. So hopefully we can explore ink starting on Monday. And yeah, for any question you can always meet us on the Central Code platforms, the Central Code, and Twitter, YouTube, yeah, and so much more. I think okay, we still have some time. I think here we can we're supposed to go to desktop. And CD to Polkadot builds. What is that? Okay, so you're going to have a directory for today called dev4, and into dev4. Okay, so that is set. Okay, you're most welcome.
Thank you.
We are almost starting. Yeah, today is the last session. Questions are welcome. Mr. Jovan, you're most welcome. I think we're 2 minutes to start. Yeah, we are going to start at exactly 19:15, and yes. You're all welcome. Today is going to be our last session on the series. Next week we are handling Ink smart contracts, and it's quite exciting. Alright, so let's get started. So we've been watching many things. We've looked at things like borrowing. There are very many topics that we haven't covered, that's for sure, but we've tried our best to make sure that we cover the most important topics. And yes, so today we are going to look at a few topics, and we call it we shall have then questions and answers, and then yeah. So first we are going to look at automated tests. So in Rust there is what we call tests, running tests, where you check for the validity of your code. For example, your code can pass the syntax error of the Rust compiler, but maybe does not bring the exact value. So in such scenarios you will be made to run some tests. So there is a good provision for writing tests. For example, you can write a test that will accept an integer and maybe bring back the sum. So your contract could be a contract that is accepting an integer and bring two integers and brings back the sum. Yet in the contract, you, instead of the addition, you wrote subtraction. Now this program will run perfectly, but now with this test, it will be caused to panic or to stop because of the custom test that you've made. So tests are mainly broken into two. We have the unit test and the integration tests. Unit tests are the ones that we do in the program, and integration tests are done by external other programs. So yesterday we ended at writing libraries. We talked about libraries in a way that libraries don't have a main.rs and are not programs, but as we had said, sorry for that, libraries give, like, they act as external entities. Maybe, for example, you could have a library that will add something and then you will then use that library in your program. We saw one of the libraries, like the rand. It is a crate which we used externally, and then we just gave it some numbers and brought back the random number in our initial stages of the session. So let me say this first test. So the way we declare libraries or crates, if we want to have them, is when we are starting, we add on the --lib to make sure that it is a crate or a library. So I can cd into first, and let's go test, and so here when we look into our SRS folder, instead of having main.rs, we have lib.rs. And as we go into building things like smart contracts, we shall find very many libraries. So we can have a look onto this code a bit. Let's be Control B. Control B. Yeah. So yes. Let me just continue. So here we have pub, which shows that this is a public function. Public function functions that can be accessed externally. So that means that if you have written your program, you can access this function within your program. Yeah. When you have pub, if we don't have pub, then that means that function is cannot be accessed externally. So this is a function that will add to take in left usize and right two variables of type usize. These are integers, and return a usize. So we have to add the two variables, and then we have a test here. This is our first test. So when we are declaring tests, declaring tests, we must start or above, put we must put above the test hash, sometimes hash test, or a test can be put in cfg. Then we have test. For example, when we looked at structs and we are seeing the debug, tests also have this to show that this is going to be a test. And then we have mod for module tests. So inside you can write as many tests as possible. Have also hash test. So when you declare it like this inside your module here, you can even put another test, hash test. So this is yeah, and you keep going. So this is how we test our work. So we look at this, that this is a function that is testing whether it works. So the result must be when we have 2 and right we have 2, the result must be 4. So we must assert equal. And yeah, so tests work in a way that if this is not met, the program will panic, and that means that the program will exit. But if you want to handle your tests extensively, then you can use match, whereby you can also handle the other side of the program in case it doesn't fulfill the test. Okay, so here we could have an example of another test. I can say fn we explore it. I'm going to just write a test that must pass. Just as long as you have the declaration has cfg, then you have the module for tests, and use super. Then when you start with this, you can write as many tests as possible, and these are very crucial to make sure that your program does what it says it does. So you can have things like assert, yes madam, yes madam, assert equal. Let me come for a while. Akandabe sina. Sorry for that, but yeah, we are still looking at tests. So we have assert equal. Here we could say maybe 2 plus 2 must give us 4. So there are many ways you can run tests, and these tests depend on your program. We shall see these more even in the Ink as a language. Okay, as we've said, you can also test your tests using the match function, which will return both the OK value and the other side of the none, which you can handle. One other thing we can look at is a depth into cargo crates. Now crates, when you go to crates.io, you go to crates.io, there are many crates that have been built to help you in case you're doing certain tasks. You may need just to use a crate instead of reinventing the wheel that has already been invented. So there are many crates. We have parity crates, so in case you need to use crates from parity, we have hyperbridge, and yeah, for whatever thing you would want to, hyperbridge has this crate. So you can click on a crate and see how you can install it and then use it. It could be that maybe you want to run a relayer and this crate will help you, or yeah, will just help you to fill in your values. So you can read about it and then see how to install it. The Stacknet crate. So there are many crates, but you can as well create your own crates. And yeah, Stacknet in Rust. So when you create your crate and you put it on crates.io, its code will not be changed. This is done for crates.io to make sure that in case someone uses your crate, or in case there are people who use your crate, that code will not be changed. So instead, if you want to upgrade that code, you'll have to just deploy another crate. Okay, so I think we can try to walk around on crates. So cargo new, you can say my crate, dash dash. This is a library that can be used by other entities. Let me close this. Hopefully everything is still intact. Okay, so we've started a crate, a new cd my crate, and then code dot. So code dot is for starting Visual Studio Code for those who use it as your editor. So the first thing you need to have when you're creating your own crate is maybe what it's going to do, but mainly you need to look at documenting it, and documenting in Rust is easy. So as we said, 2 slash bars are for a comment, but when you have 3 forward slash, it's for a documentation. So this can be a documentation, which is as well as a comment. Documentation doubling as a comment in Rust. So probably let's create a crate that will add 1 to what is given, just for the purposes of learning. So I can say this, because we create this for others to use. Instead of rewriting this boilerplate code, they'll just call our crate and then use it. Just pass what they want to pass. This adds 1 to the value given. So now what I'm doing is also documenting as well as commenting. Maybe let me make sure that the documentation is clear. And this will skip a line and give an example. You can also skip another line, and those that have written markdown, maybe in your GitHub readme. Yep, some of these are very useful. This is where we are going to write some code. So we can say maybe probably when we have let the argument be bound to 5 or be assigned to 5, then we can call an answer. So this means that if a user is going to bring just a value, it could be x or it could be an argument, any argument. So we can bring an answer. So this will help the person using the crate be assigned to my function, which is I can call it my answer or my crate. And then add 1 and pass in the argument. So this will just help the person that is using our crate to read very well. You can also give them a test to run to make sure that the program works as we ought it to work. So if we passed in 5 and we added 1, we shall get 6 as the answer. So if they pass in 6, 7 and add on 1, they get 7, but for this case, yeah, that is it. So now we are going to write our function. So we have finished our documentation, and the function could be, you can say add 1. So all this, whatever you see 3 lines, these are for documenting, and we are going to be looking and seeing how that comes about. Fn add 1. So this is our function. Then value that we have been given, which shall take of type i32. So this value will be passed in by the user or the person that is using the crate, and then we return an i32. So yeah, this is what we have to return, that value plus 1. And since we are returning, we don't need to use ending semicolon because we are returning. So now when we have such a thing, we can generate out that documentation by running Control B, by running cargo doc. So when we run cargo doc, documentation is created in this doc my rate. We can either pass this to a search engine like Google Chrome. We can also see it home, target doc my crate index.html. So target doc, so a document has been created, my crate, and then index. Or we can copy it and paste it here. so that we view our documentation, and you see that we have a very good documentation. Now you can improve this documentation, of course, by reading more on how to document, and we can see my crate, you can see functions, you can click on many things, so adds a value to this. When we click to it, we see this sample. You can have some examples whereby even this is shown here. Yes, so this is a full documentation that we have written for our crate. Okay, if you want to open it from here, you can write cargo doc and then dash dash open, so it will automatically open in the browser. And that's the first step when you want to publish a crate. Secondly, now we go to adding metadata, and things that will be defining our crate. So our crate must have a crate name. So when we open cargo.toml, I want this to be a bit small. So when you open our cargo.toml, we must make sure that we have the name. We have named my crate, and if this crate is already available on crates.io, you'll be prompted to use another name, a different name. You must have the version that is already named. So some of the things that we need to add are the license. Many use MIT. We need to add a description, like a one-line description, and all this is added here. You can even add iterations, but yeah, create for adding one to value provided, and yeah, many more things. So after that, to publish your crate, you go to crates.io and then log in. Crates.io makes you log in with your GitHub. So after logging in with your GitHub, you go to account settings. So this is visible, and then you get an API token. So the API token is here. If you don't have, you can revoke if if you think that your API token has been used. You can create a new API token and things like that. So just for sampling, let's create a new API token. Sampling. Of course, we are not going to upload this crate. Here you have to tick like the pose that you're giving to the token. Generate token. So after generating token, you have to revoke it, because other people can use it after. Yeah. So when you copy it, you can come to your crate that you finished to create, and I think it is called crate login. It's called cargo login. You type this to help you log in, and then you paste your key and enter. So I've logged in my crate, and after that I can do cargo publish, which will publish my crate onto our crates.io. So that's a basic way of publishing your crates. You can also pull crates to use in your program, if you're writing a program using cargo install, or just adding them to adding them under dependencies in your cargo.toml. Okay, until then, do we have any questions? I think I can continue. I'm going to go to the last bit of these sessions. So these sessions were just to break loose Rust so that it is easily understandable and easily doable when you're going through it. The last we can talk about is unsafe Rust. So what could unsafe Rust be? Unsafe Rust is Rust where you want to explicitly tell the Rust compiler that I know what I'm doing. It is okay, but I know what I'm doing. For example, there are scenarios where the Rust compiler will panic and exit the program, and you do not want to have, and you know what you are implementing for the program, and you want it to behave that way. So that's when you can have unsafe Rust. You can tell your program that, you know what, I know that this is I know that I'm doing this, and the way we do it is we add unsafe before the attribute that we are declaring, so that Rust does not mark it as a bug and then panic. Okay, I can give just a very simple example. Rust unsafe. I encourage us to go and read through the Rust book. It's a very detailed book. I often go back to it and read through it whenever I get stuck and things like that. So cd rust unsafe code dot. So I can open my okay. So you can have a scenario where for example, I can say let mute have a mutation value, let mute be assigned to 5, and we want to have a sort of a pointer to this number. Maybe I can select R1. I want to get a scenario where I can have an instance where I want to explicitly tell the Rust compiler that I know that what I'm doing, so please don't panic and exit the program. So I'm writing my R1 to be the reference for now. We've used as const. So this is we are referencing, and we are giving to R1, and we can select R2 probably with the reference to the number. Since R1 brings a mutable value, I can set be a reference to the mutable value of the number as so when you have such issues, Rust program is most likely to return an error if we print these R1 and R2. But for this case, since we don't want, let me remove this. If we don't want Rust to yell at us, we want to can put this in unsafe. So unsafe is declared before. So and this shows that does not show that Rust is unsafe, but it's like saying that I know what I'm doing. Don't take this as an error. We print those pointers and see if Rust R1 is lifetime. So R2 okay. Yep. So let's try to run cargo run. You find that our program has compiled, and if we remove the unsafe bit, you see we already have our Rust compiler warning us that this operation is unsafe and requires an unsafe function or block dereference. So because this is a dereferencing symbol, here we are trying to dereference, yet we are referencing, and now we are referencing it as an I32. So yeah, so now if we tell Rust to that, you know what, we know that you want us to reference, but we know what we are doing with unsafe, then everything is okay. So this is crucial, but can cause a lot of issues. I need when you've really been doing a lot of practice in Rust. Yes, so for today's session, I think I can end there, and we have a chat, question and answer, suggestions, and anything that you would want to know. If you anticipating something, could be an hackathon, or yeah. Mr. Jovan, are you on chat? Mr. Joseph, are you also on chat?
Yes, thank you, Brian. I really appreciate it for your efforts. I think at the moment, I should say I'm on track.
Okay.
I think, and of course, you need to practice as a person.
Yes, that's
so.
very
I've been trying to make it a point that after every session, I practice, but maybe more practical applications of what we've covered, and then that one can be in form of, those short, maybe trial, just to apply the knowledge we've gotten.
all right.
And then maybe, of course, the end goal is to see my expressions.
Okay.
So it's used in blockchain. Yeah, that's my expression. Okay.
All right. Thank you for that advice. Yes. I think actually, as we go into Ink, we are going to be having smart contracts and like more real world use cases. We are planning to start a custom blockchain with a substrate. So there is more coming. I'm also pushing for something if we can have like hackathon thing where at least if projects start up something and they can be given some kickstart. Yeah, we are pushing on that. I cannot say much, but yeah, in case that comes up, those that will be building on Polkadot, if you're starting something, yeah, it will. I think to work out. I'm still in that process. Hopefully, it comes out well. But even if not that, the power of open source is also very good. So yeah, great work, man. It's really a pleasure that you've kept it this far. Rust is not easy. That you keep on and keep pushing.
Thank you for the sessions. I don't know if I'm audible.
Yes, you are audible.
Yeah, yeah. I've been lucky following. I think I'm going to go back. I have to go back and look through the unsafe trust. It's something that I've really, it's not something I really wanted to go and brush up on.
Okay.
So yeah, it is something that I'm looking forward to the session. So yeah, but yeah, good session. I'm rubbing my fingers and I'm licking my lips for the day when we start doing ink and substrate. Yeah, so that's what I'm looking forward to.
Ink is coming next week. By the way, we have a space tomorrow. If you're on the Decentral Code Twitter, we have a Twitter space tomorrow. It's already set. Yeah, you could be in as we discuss many of these things. But yeah, ink is coming next week.
Yeah. Okay. Looking forward to that.
All right. Any other submissions? And since today is our last day, I want to let everyone express their feeling and see how we can do better, how we can push on. There have been very many improvements also on my side. I think with the recording, every day we improve something, and you can even see it in our live sessions, also in our recordings. So kudos to all of those that are in the background. Mr. Jovan, sometime being lucky. Mr. Boss has been here to the end. There's also another gentleman here. If you don't mind, you can come and say hey, Mr. Arnold, or if it's okay, we can. Yep.
Yes, good evening, guys.
Good evening. How are you?
Yes. Like I'm a friend of Jovan, and I saw like on his status, like there is a link, a Google Meet that is happening, and he was invite everyone to join. Yesterday I wanted, but maybe I was late. I saw it late, but today when I saw it, I wanted to join and see what you are like. You're doing something good, learning together. That's something better. Yeah, I like it.
You're welcome.
Yes,
we are always in these spaces and pushing the boundaries. Mr. Jovan, great work. All right, any other submissions?
Yeah, I saw like you are doing Rust. I don't know where like the step you are now.
Okay,
because I joined late.
Yeah, this has been our last session, but we record this and put them on YouTube, on the Central Code YouTube channel, so you can go through from the first session to this session and then kickstart your journey in Rust.
Okay, thank you.
Yes. Next week we shall be having Ink. Ink is built on top of Rust, but now this will be Rust in detail, like going to use cases, writing Ink smart contracts and things like that. But you can as well watch the tutorials anytime that you get.
Okay.
All right.
Yeah. I think I will reach out to Jovan and ask him use the channel of YouTube.
Yeah, you can also check in the chat. Hopefully, yeah, there is something in the chat, but you can as well reach out to him. Okay. Any other thing? So we are anticipating for ink. Mr. Jovan, what do you want to see with ink smart contracts? The complexity, how we handle it, or tell me.
Just the power of building mini blockchain. Because when you look at how we do in Ethereum, you're just building small smart contracts. I want to see the moving parts of how you can build small blockchain. You know, that's really powerful.
That's powerful. I also like that experience. I've already organized my machines in sessions for Substrate. We shall really have live sessions where I can have two computers presenting and we see this power, because it is really powerful. It's powerful to see things like consensus in play, grandpa, aura, all these things where you have authorities. Yeah, so okay, be anticipate. But next week it is ink. Ink is also huge. We shall build some smart contracts and hope all goes well. I think we can say it's we can have it as a day. Otherwise, there's nothing more. Yeah, we can. Okay. So see you next week, and in the Twitter space, in the X space, and bye bye.